In this lesson video, we are going to discuss about the basic material settings that we can find in the principled BSDF shader. There are 4 material properties that we are going to cover in this lesson. First is the metallic value. Second is the base color value. Third is the roughness. And lastly, the transmission value. To get you started quickly, I already prepared a Blender file named Basic Material Properties Start.blend. If you open the file, you will see one monkey head object with a subdivision surface modifier applied to it. You don't need to worry about this right now because in this lesson, we only focus on the material settings, okay? I also set the viewport shading mode to look depth as you can see up here. Now, if you select the monkey head model and then open the material properties panel, you can see that the object doesn't have any material applied to it. So let's create a new one by clicking on this new button here. The first parameter we are going to discuss is this one called metallic. As the name implies, this value determines whether the material is metallic or not. In the real world, we can categorize materials into 2 big categories, metal and insulator. Examples of metal material are iron, gold, copper, chrome, steel, etc. Metals are all good electrical conductors. On the other hand, insulators, or also known as dielectric materials, are materials who are bad in transferring electricity. Materials such as wood, fabric, glass, rubber, plastic, etc. Basically, anything that is not metal is considered to be dielectrics. To see the metallic effect better, first, let's turn down the roughness value here all the way to 0, okay? So, the physically correct way to set up the metallic value is to set it to 0 if the material is dielectrics, or set it all the way to 1 if it is a metal material. In the real world, there is no value in between 0 and 1 as there is no such thing as half metal, half dielectric materials. Now the question is, why in the world we have slider in here and not an on-off checkbox? Why Blender let us set the metallic value between 0 and 1? Well, this is because not all 3D projects aimed for physically correct or photorealistic rendering. Some projects prefer to have a more stylized look. So it all depends on you as the 3D artist. Again, if you are aiming for photorealistic rendering, then you should stick with using either 0 or 1 for the metallic value. But if you are aiming for a more stylistic look, you can choose any value in here between 0 and 1. And you can even exaggerate the value to be higher than 1. To do this, you need to click on the slider and then type in the number manually. For example, 10 or even 100. This will make the material super metallic. Of course, you will never see material like this in the real world, but this can be used to create interesting visual effects. Let's change the metallic value back to 0. The next parameter is the base color value here. Basically, it is used to define the color of the material. For example, we can change this material to red or to blue, etc. This is a very basic stuff, but there is one thing I need to mention about this base color is that it will serve as a different purpose depending on the metallic value. If you set the material as dielectric, this base color value will be used as the base surface color or also known as albedo. But if you set the material as metal, then the base color is not actually used as albedo, but rather for tinting the reflection color. You see, in the real world, it is simply impossible to see the base color of metal materials due to its reflectivity. Simply put, all metal materials don't have any base colors. What we see as yellow in gold, for example, is actually a colored reflection of its surroundings. So again, metal materials have the ability to colorize or to tint the reflection. And in order to do that using the principled shader is by using the base color value here. The next important value we need to discuss is roughness. In theory, roughness value controls the amount of microscopic hills and valleys of the surface. High roughness value will make light rays hitting that surface to bounce off in random directions, while low roughness value means that the surface is smoother. Therefore, the light rays will bounce off in a more predictable manner. Essentially, if we set the roughness value to 0, we will see clear reflections and sharp highlights on the surface. And as we increase the roughness value, we will get more blurred reflection or less highlights on the surface. If we set the roughness all the way to 1, we will have a pure diffused material. The last material property we want to discuss in this lesson is transmission. Basically, this property determines how much light can pass through the material. So with this property, we can simulate refractive materials such as glass, crystal, emerald, water, ice, oil, etc. Let's see how we can do this. But first, make sure the base color is set to pure white and the roughness value is set to 0. And now, let's increase the transmission value here all the way to 1. We can see now the material looks like a glass or crystal, okay? Now, while the material has a transmission value like this, you really don't want to turn the metallic option on in here. Why? Well, this is because all transmissive materials are dielectrics. There are no metal material who happens to be a transmissive material at the same time. So again, if you use transmission value down here, you should always avoid turning on the metallic value up here. That is, if you are aiming for a physically correct result. Okay, next, we can control both the color and also the transparency of the material using the base color value. To do that, let's click on the base color so we can access the color picker. If you have your material in transmissive mode, when picking a color, it is better to use the HSV color model. This is because each of these HSV values controls a different aspect of the material. First, the value or the V parameter in here. In transmissive mode, setting this value up will make the material more transparent, and setting it down will make it more opaque and also darker. Next is the S or the saturation value. This saturation value will affect the tinting strength. But we need to increase the V value again to see the effect, okay? So 0 will make it clear like pure water. And if we drag the value up, we can see we get more color tinting on the material. Now this object looks like a ruby. The last one is the H or the hue value, which basically controls the tinting color. For example, we can make it green like this. So now it looks more like an emerald.